Question 1, 2, and 3A must be done in the tutorial class, facilitated by the tutor. The rest of the questions labeled as assignment 1 task must be done as take-home exercise as part of your assignment 1. So, question 1 says build an NFA separately for each that accepts the following languages. That is, each of these is a separate question. Okay, each of them are a separate question. So we are doing 1A. After that, question 2 says obtain a DFA for each of the NFA built in 1A above. Meaning, for each of these NFA that you have constructed, you have to construct a DFA. So meaning, like we have 1A, then 1B, 1C, 1D. We will have 2A, 2B, 2C, 2D. Okay, 1A, B, C, D is NFA for each of them. So 2A will be DFA for this, 2B will be DFA for this, 2C will be DFA for this, 2D will be DFA for this. Okay? Alright. So what we do is when we do 1A, we do 2A as well. NFA, then its equivalent DFA. Okay. Strings over the digits 0 to 9. So here the alphabet set is the decimal digits 0 to 9. Okay. Which contains at least 3 ones. Okay. Which contains at least 3 ones means 3 number of ones. Okay, 3 number of ones. So alphabets are 0 to 9. So meaning my smallest valid string will be 111. My smallest valid string will be 111. I can have something like this also. Not necessarily it has to be 0. As far as I have 3 ones, my string is valid. So my string can have any combination of 0 to 9. Any combination from 0 to 9. Okay. Only requirement is it should have 3 number of ones. So the smallest valid string will be just 3 1. You can do it as 3 1 or 111. It's the same. I can have some situation like this. Not necessarily it has to be 0. I can have any number. I will give you a direction. After you start, okay, before you reach the final state, you should have processed 3 ones. After you start, before you reach the final state, you should have processed 3 ones. So what we do usually, we usually construct. When we write grammar, the very first step is to write the grammar for producing the smallest possible string. Then we cover the next and so on. Same style you follow here. Construct the machine to accept this. You have almost solved the problem. Construct the machine to accept this smallest possible string. Once you have done, you have almost solved the problem. Okay. Then once you have constructed the machine for this, you can improvise to accept this, etc. Yeah, done. The B. Yes, 777. Yeah, in this scenario, you will not have 777. You will have 3 sevens. Yes. If you draw like that, you won't get. You should not have 777. This one will have 777. Okay. So what you should do? Yes. If you're not done, That same, yes, you have to exclude. You can have, see, let us finish this first. Because I have to explain here. Then this one will be lost. Hey, I haven't even solved this, suddenly you are here. Yeah, they will be lost. I will explain. Done? Question 1 done? 1A done? Anyone want to share the answer for question 1A? Why don't you share the answer for 1A? Check whether you have the same answer. Last one is 0, 9 or 0 to 9? Dash 9. That's all. Thanks, very good. See, by doing this, you cannot reach here without reading 3 ones. Okay? So before the one, this one, you can have any combination of 0 to 9. This is same as writing like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you do this on paper, it will look like, your diagram will look like an ant colony. Okay? So everywhere I did something, it won't look nice to see. Okay? So this is same as writing like this. 0 to 9. Okay? So before this one, we can have any combination of 0 to 9. And after this one also, you can have any combination of 0 to 9. Right? Yeah. So can you do the DFA? Why this is an NFA? When you write 0 to 9, you have a 1 year. Correct, right? When you write 0 to 9, you have a 1 year. You also have a 1 year. So if you give input 1, the machine can take this path. Actually, this string is a valid string, right? It's a valid string, right? I can just trace this string at Q0 itself. 9, it's already here, right? 9. I also have a 1 here. 1, 8, 1, 6, 5, 4, 3, 2, order project. There are many order projects. 9, 1, 8, 1, 6, 5, 4, 3, 2, 1. Order project. Y means there is a 1 here, there is also a 1 here. There is a 1 here, there is also a 1 here. So in all these states except for this, in all these states, 1 is redundant. You have duplicate for 1. That is more than one route or one path for 1. That will lead to non-determinism. Some path will work, some path will not work. So for this string, there is only one path, 9. For the first one, I have to come here. 1, right? 8, 1, 6, 5, 4, 3, 2, 1. That's the only path. Other path all will not work. Okay? But as far as there is one path that lead to success, it is an NFA. There are many paths that doesn't work, but there is at least one path that leads to success. It's an NFA. Okay? So we know where is the problem. But what is the cause of the problem? If you can remove the cause, become DFA. So what we should do? We should remove the 1 year. Remove the 1 year, remove the 1 year, remove the 1 year. But not 1 year. 1 year, 1 year, 1 year, remove it. How to remove it? I remove the 1. 0, 2 to 9. Okay. Now it becomes deterministic. If you take this one, 9. See, deterministic means there is no choice. That's what I want to emphasize. Deterministic means there is no choice. There is only one route. If it is a valid string, it will go and reach the final state. If it is an invalid string, it will halt and reject. I will show you both. I am taking this now. 9, no choice. 9 means it has to process here. 1 means no choice, it goes here. 8 means no choice, it goes here. 1 means no choice, it goes here. 6 means no choice, it goes here. 5, 4, 3, 2, 1. I take an invalid string. 1, 2, 3, 4, 5, 6, 7, 1, 2. It's an invalid string. Why? Because I have only 2 ones. Correct? So, 1 means no choice, it goes here. 2, 3, 4, 5, 6, 7, 1, 2. It halts here. If it halts here, halt and reject. Okay? Question should only halt here because we have a final state. Okay? So, invalid string means it will halt and reject. Valid string means it will halt and accept. Okay? So, we have solved 1a and 2a. So, let me explain this, and you can try it at home. And on Friday, try it at home means not take home. Not this assignment 1. Assignment 1 has been labeled separately. I will explain that on Thursday's class. Okay. So 1b says string over digit 0 to 9, which contain 777 somewhere in the string. Which contain 777. This and this looks similar, but not the same. It says at least 3 ones, 3 number of 1, not 111. Here it says contain 777. So what will be the smallest possible string? Okay. So 777 means this 3 7 should be always together. That's why I said 777, not 3 number of 7. Right? 777, should be always together. So what can be the next possibility? I can have 0, 777. I can simply say I can have 0 to 9, any number. Then I can have 777. Okay. And after this 777 also I can have any combination of 0 to 9. Okay. So I can have something like this. Which contains, okay. 0, 1, 2, 7, 5, 6, 777, 8, 9, 7 is also valid. As far as there is 1, 777. Okay. It says which contain 777 somewhere in the string. As far as there is a 777 in the string, it is valid. Okay. And this is opposite of this. I can have just 7. One C here. I can have 17056. I can have 777. Okay, any combination 0, 1, 2, 7, 5, 6, 7, 8, 9, 7, 7, all are valid. As far as I don't have 777. So I can have 1 7, I can have 2 7, but I cannot have 777. Okay, should I have only one time 1 7, 2 7? No, I can have many times. You can see I have a single 7 here also. I can have many single 7, I can have many 777, but I should not see even one 777. Okay, this is very similar to this. There's a small tweak. You tweak this answer, you already have 1B. Because 1A says 3 number of ones. Okay. 1B says 777. That's all. Not 3 number of ones. 3 sevens together. Welcome. You are 12 o'clock class. I mean, 1 o'clock class. Maybe he got the lift. He got the lift, so he's early to class. Not early class, only 1 month. The rest of them are not there. Maybe they have another class. So they are there. It's going to be. Okay? You may have a class over here. So we will continue on.